Okay, welcome back. So I was talking about the concepts involved. These are very important, good people. Uh, at first, let's talk about these two turning points. Yes, we are very familiar with the turning points. For now, when we are dealing mostly with cubic function in calculus, sometimes we will not refer to these points as turning points. We are going to refer to them as stationary points. Stationary points because it's like the graph is stationary there. It rises, and before it decreases, it stops for a while there and go down. We know when you are throwing an object, upwards. Before it comes back, you got to for a very short time, and then it comes back. It's something like that. So turning points now will be referred to as stationary points. So what is important about stationary points? If you look at the stationary point, if you were to draw a tangent at a stationary point, you would realize that the tangent layer would be parallel to the x-axis, and then any horizontal line, usakhumbula ukuthi sathini nge-gradient yawo, the gradient is equal to 0. I-tangent edlula kwi-turning point injani, parallel kuma-x-axis, so which means it has a gradient that is equal to 0. And with turning point bakwethu, if we say the gradient is equal to 0, remember what is the gradient? The gradient is the derivative. So which means if this is a function defined by f of x, it means with turning point the gradient is equal to 0, therefore the derivative is equal to 0. Good people, that is very, very, very important. I don't know how I am going to stress that. You might look at this another way. The gradient, if the function is rising, the gradient is positive. So which means as the function is rising this side, the gradient is positive. The gradient is equal to 0, it's greater than 0, the derivative is greater than 0. Then it becomes 0 at the turning point. After that, it is decreasing. When the function is decreasing, it has a negative gradient. Therefore, after the turning point, the gradient is negative. Therefore, the derivative is less than 0. Then at the turning point, the derivative is equal to 0, or the gradient is equal to 0. Then after the turning point, it starts increasing again. It's positive, which means where it is increasing, the derivative is greater than 0, or the gradient is greater than 0. Okay, let me break this. I will continue after this.